Good morning. We're going to be streaming today some more Erlang stuff. So, yeah, stay tuned. Just getting started with my day here. It is 1 p.m. Had my lunch. I even went running for the first time today, so yay me. I've run before. It's just first time in a while. Oh, there it was. Sometimes I leave funny things in funny places. Um, Yeah, so what's Erlang? Erlang is no, I ran for the first time in a while. I really want to start exercising for not just losing weight, that would be nice, but mostly for mood balancing and just like help the brain be clearer. Yesterday I was doing this other part on Erlang where we were doing reverse Polish notation calculator and it was so hard. And I was like, shit, I gotta do something about my brain. So here we go, running. So today was really short. I just basically went around the block once because I don't want to overdo it and like I don't know mess something up, which is kind of like what I usually do. Just like, all right, we're gonna run, so let's just go all out, and that's just crazy. Like starting a new habit, go slow. Don't go overboard and hurt yourself. All right. So what's Erlang? Erlang is a language made in 1986, so it's kind of middle age. It's not like old like Fortran and COBOL or maybe C, but it's not new like Rust and Zig and all of those languages. Um, it kind of has some influences from Prolog I read. But basically, it's used for very like parallel systems for things that are running a lot of concurrent processes on lots of CPUs or cores across distributed machines. So that's what that does. Um, WhatsApp and Discord uses it. I'm not sure who else uses it. It's built on top of Beam. So if we look at Beam VM, maybe this will tell us like what runs on it. So here's some languages. Um, Most popular is Elixir on top of it, but there's Gleam and some others. But we don't see like what companies use Erlang or Elixir. Um, let's see here. Companies like WhatsApp, Klarna, and many more. Don't know what Klarna is. Fintech company. All right, well, sounds good. Discord, Square Enix. Oh, I had no idea. They use Elixir for user authentication. PepsiCo, Bleacher Report. Haven't heard of these guys though. WeChat, WhatsApp, and Facebook. Erlang is one of the secret weapons that enabled the team to create a product that could serve 900 million users with only 50 engineers. So there you go. They use, wow, Riot uses Erlang? Guys, you guys should be learning Erlang with me. You can join Riot Games and play League until you get so toxic that you quit. All right, so where do we leave off? So we learned quite a bit of Erlang already, at least the syntax of it. We learned basic stuff. We learned like basic types like tuples, lists, and atoms, and those kind of things. We learned how to make modules, which are basically namespaces or packages, whatever. Syntax for guards and conditionals. Guards, since it's a dynamically typed language, guards are kind of important. They basically put stuff around your functions. So you say what types each of the parameters sort of are. And that way, at runtime, at the very least, it can tell you that there's a problem. But sometimes at compile time too. Type conversion. We learned some recursion stuff. We did quicksort, yay. Higher order functions. We made our own map, maybe our own fold, I don't remember. We learned how to throw exceptions, how to throw stuff, and how to have errors and what the difference is. And now we're here. But notice on the browser, oh shit, I'm not showing you anything. Um, and now we are here, but notice on the browser, we still have quite some ways to go. But let's not focus on that. We're going to try to do this part here. I don't have that much time today. I got so much to do. So let us try to get started as soon as possible to do this stuff. So let's read this. We're going to be doing this problem. Our next problem is also from Learn You a Haskell. Great book if you haven't read it. You're on a plane due to land at Heathrow Airport in the next hours. You have to get to London as fast as possible. So you're here, and you basically want to find the path to your rich uncle who is dying, and kind of whoever gets there first gets to claim dibs on his estate. So for whatever reason, I guess it's important to get there as soon as possible. So these sort of like paths, I guess, like you want to figure out which is the fastest way to get there. So you want to solve this problem using Erlang because you've read online books such as this one, and you're like, God, wouldn't it be cool to use this? So let's enter the data into a file called road.txt. Sure. This is probably not useful. There, we call this road.txt, right? You guys see that? Yep. And what is this data? The 50 is this 50, then the 10 is this 10, and the 30 is this. So basically, it's A. So these are all A's. 55, 40, 10. So that's probably 55, 40, 10, right? And then we get all the B's, 10, 90, 2, 8. And then we get all the crosses, the perpendicular ones, 30, 20, 25. And the last guy, 0, because when you reach the end, you don't have to cross. It's kind of like a finite state automata, like these transitions, right? Um, Not really. Well, I guess. The road is laid in the pattern A1, B1, X1, A2, B2, X2 to AN, BN, XN. So kind of what we said earlier, where X is one of the roads joining A side and B side. So it's kind of this grid thing. We insert a 0 as the last X segment because no matter what we do, we're at our destination already. So basically, we wouldn't take the X at the end, right? Doesn't make any sense, but even if we did, it's a 0. So when we read this data, we should probably organize them into a tuple of 3, a triple, ABX. So we'll basically have a list of ABXs. The next thing you realize is that it's trying to, you should basically solve this by hand. So they're trying to figure out how to do this by hand. And we need a base case because we do recursion, right? So if you have a 10 and a 15 here, Obviously, the solution's easy. You do a 10, you're done. So the choice here is A, 10. Super easy because the x is 0, remember? So it doesn't matter. So now we extend it. So instead of the 10 and 15, now we have 5, 3, and 1, which is basically a triple, right? We have A, B, and X. A is 5, B is 1, and X is 3. So we kind of want to figure out which way is the best. I guess we want to figure out if it's better to take A or to take B or to take A and then X or B and then X, right? So let's look at all of those. A is 5, B is 1. So obviously B is better, right? But we need to know, like, basically this might be better in the long run, the top one. We just don't know, right? So if we do the top one, is it better? I guess if we want to do the top one, is it better to go 1 and then 3 or then do 5? So those are only two options. We can basically only end up in either this point or that point. So we just need two solutions, I think, and then it's recursive. So I think that even if we want to get to the top, 1, 3 is better than going 5. And then if we want to go to the bottom, 5, 3 is way worse than going 1. So it looks like our two options that we should consider is 1, 3 or just 1. And then we solve the problem, right? So we're on the top, and now we basically, if we take the top path, the 10, we have to add the 4 that we got from here. So this would be 14. And if we go on the bottom path, we would take the 1 that was from here, right? So that would make it a 16. So we have 14 on top or 16 on the bottom. So the best path is basically 1, 3, 10. Let's see if they say it the same way. We have 5, 1, 3. Yes, that's right. That's the triple. Uh, strict choice between A and B. How many ways to get to possible for A? To get to the intersection of A1 and A2. Basically, A1 and A2. I guess that means this, right? The top one. I'll call this point A1. That's kind of confusing, isn't it? You can either take the road A1 directly, 5, which we said, or come from B1 and then cross over X1. In this case, the first option, 5, is longer than the second one, 4. For the option A, the shortest path is BX. It's interesting. You could store the solution in terms of B's and X's and A's, right? You just do A, B, 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 X, or whatever. So what are the options for B? You can either proceed from A1, 5, then cross over to X1, cross over X1, or strictly take B1, which is 1. And we said that 1's way better. All right, what we've got is a length 4 with BX towards the first intersection A, and a length of 1 with the path B towards the intersection of B1 and B2. We then have to decide what to pick between going, yeah, this is basically what I said. Um, 16, yeah. In the path BXA is better than BBX. BXA is better than BB, BXA. BXA. Or BBX? BBX. What does BBX mean? That doesn't make any sense. Anyway, what are they talking about now? Didn't we kind of finish this yet? I don't know. I hope that what I said was right because this sounds like a lot of text to say the same thing that I was saying. So where are we? Ah, yes, we have the file we're going to feed in as input ready. To do file manipulation, the file module is our best tool. Here is the file module. File. Types. We haven't really learned types. List directory, make directory, open, path, pread, position read, read. Anyway, it contains many functions common to many programming languages to deal with files themselves. It also contains useful functions to read and write from files such as file open and file close to do as their names say, opening, closing files. File read to get the content of a file, read line to get a single line, position to move the pointer. There's a bunch of stuff. Let's see if we have to read a file, open a file before we, oh my, before we do anything. Let's see. What was it called? Road.txt? Road.txt, right? So we can do file colon read like they have here. Read file road.txt. Let's see if this works. Okay, yeah, it does work. So we have the numbers. And then we can split this, right? Wasn't it like split? Oh, string tokens. We take this and we pass it in the new line. Ah. So we have to, it's going to return something to format OK and the binary data, the bit string. So we do this. Oops. We do this. Oh, hold on. This returns OK. Ah, we need this to be capital letter because that's how variables work. And now raw content has this bit string. And now we can string tokens on raw content. Looks like we can pass it the new line. No? String tokens. They're calling binary to list. Oh, because string tokens doesn't work on a bit string. It works on a character list. So we need to call was binary to list. Got it. Yeah, so you see when it has these things, go back to the video with binary syntax and you will find that. So we're turning it into a string now. You notice it has no more of the greater and less than signs surrounding it. So this is a character list. So then we can call string tokens on this with new line. And now we have the numbers. Perfect. Isn't this? Oh, we need to turn these into integers. So we basically say this is our, we'll just call it T for token, right? And what we want to do here on our comprehension is call, what is it called? List to integer. Is that what it is? Yeah, list to integer T. And now this turns it into a list of integers, just like we wanted. All right. That's kind of what they said here. So now we're going to make a new file. We'll call this row.url. So we already know we're going to need module and pass in the name of the file. That's not URL. It's road. Okay. And what are they doing here? Main file equals road read file parse map. All right. I think it's good to try to not look. So we're going to have a main function. I think it took in nothing, right? And it's going to do file read. And then so it needs to know the name of the file, road.txt. Wasn't there something else in read? Here, let's start slow. Not this guy, this guy. Compile road, and then we go road main. Undefined function read, so it's not file read. It's probably that I did it with the wrong number of things. Let's see here. Oh, it's called read file. You look great. Oh, um, I like the one on your right. Yeah. All right, so now we've read the file. Maybe we should do what we already know we're going to need to do, right? So after we read the file, this is going to be in the format of OK and the raw data, right? Raw tokens. And what is the raw tokens? This is raw bit tokens. Okay, and after we have the bit string, we want to turn it into a list, right? So we do list, no, we do binary to list, I think, right? List is string, and we pass in the raw bit string. There we go. And then after we do that, we want to turn them to numbers. So we can call this car list. I don't know. I'm terrible at variable names. Usually in Elixir, you'd have some kind of pipe operator, so you don't have to even name these things. I'm guessing Erlang has something like that. I just don't know what it is. So anyway, where are we? No, maybe it doesn't have it because didn't that come from like Ruby? Anyway, right. So here we're gonna make the list comprehension where we call list to integer, and we're gonna pass in whatever the n, and n is being created from car list. So what we could do here is just remove this part and put it here. And maybe that's better. Let's see if this works. Not a list. It's not a list. Oh, we have to separate them first. We haven't turned them into individual, we have to call. So what we'll do here is we'll do string tokens. I think that's what it was called. Char list, comma, new line. And this will be called oh my god. Let's not call this anything. Let's just copy this and put it here. That's not what I wanted. String tokens char list. Because my editor's not happy with me. There we go. All right, still not happy. Char list is unbound. All right, let's see if this works. There we go. So now we have a list of numbers. Oops, what happened? That was really weird. What just happened there? Oh, did I click here? Yeah, I clicked here. Main parse map, I see. So they made subfunctions for these things. That makes a lot of sense, huh? Parse map raw bit string. Then they had parse map basically take in the data. They called it bin. And then we can do when is binary bin, right? Yeah, that's what they do. And then we call, in this case, we call binary to list. And then we can call parse map again. No? Yeah. I see they put it here. Parse map. I feel like this is a little harder to read. And now that turns it to a list, so we need a list version of parse map. I'll just call it S when is list s. Is that what they called it? Yeah, is list. Oh, I like str. That's a good one. Gotta look at their conventions. And then here, if we get a list, we need to convert it to a list of integers. This is just bin. And why is this guy unhappy? Oh, because parse map is already defined. Oh, I see, because I need to do this. That makes it a function clause so that this is another definition of the same function. All right, let's see if this works. It should give us the same results, and it does. Okay, here we go. Now they explain what's happening. The next step in parsing the map would be to group the data into this triple ABX. Sadly, there is no simple generic way to pull elements from a list 3 at a time, so we'll have to pattern match our way in a recursive function in order to do that. So what does it do? It group values, passes in a list, and I guess when it's empty, it reverses the accumulator, probably because we're going to be putting them in the front all the time, just because it's more efficient, I'm guessing. So we have to, and we're doing it recursively, so it's going to be stacking it backwards. So then when we get to the base case, we just reverse whatever we've accumulated so far, and then that's it. Otherwise, we read the first 3 elements, and we call ourselves recursively with what's left, but then we add the triple into the accumulator. All right, let's write this. So we have a helper function group vals that takes in a list, right? Yeah, takes in a list and an accumulator. And if the list is empty, then we just have to list, maybe it's list, reverse. And then we pass in the accumulator. Otherwise, we have a list where we have an X, we have an A, a B, and an X, followed by whatever's rest. And we have the accumulator. And what we want to do is call ourselves recursively with group vals with the rest, so we're getting closer to our base case. And we want to put stuff in our accumulator. So we take, here's the new list. The new value we want to put is ABX, followed by the rest of the accumulator. So we're constructing a new list there. That looks right to me, I think. Group vals. It's going to be a helper function probably. So maybe we put it here. Well, why don't I just I'll just test it for now. So what I'll do is I'll add it to our output list. so that it won't complain. We compile it. Now we need some test variables, test data for group vals. We give it the accumulator is going to be empty, but the very beginning one's going to be like 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is like groups of threes, and our accumulator is empty, and it returns us 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that works. And if we give it an incorrect number, it'll fail. All right, so I think we did that okay. Here's group vals. Does that look the same as what we've done? Yes. Parse map. Yeah, so that's where I was going to put it too at the end of this one. So we just change this to a comma here. And then we call group vals on our... Uh-oh, we need to store this val. We need to store this. Okay, so now we have group values. And we start with the accumulator is empty. There we go. So it took it and it turned it into the tuples that we talked about. Great. To decide what to use as an accumulator, the method I find easiest to use is to imagine myself in the middle of the algorithm while it runs. This is a good idea. For this specific problem, I'll imagine that I'm currently trying to find the shortest path of the second triple, 5, 90, 10. So here we are, 5, 90, 20, sorry, to decide which path is the best. I need to have the result from the previous triple. Luckily, we know how to do it because we don't need an accumulator, and we got all that logic out already. So for A, I don't know what they're saying. So for A, the path starting at A is length 50. So BX is shorter than A. Pick one. Or are they saying this? BX is shorter than A. So pick that one. Yeah. For B, it was similar. Started B as 10. Right. So basically, they're just trying to find out which one was better. So now we know that the current best path coming from A is BX, and we know that it has a length of 40. Right. For B, it is simply B. We can use this information to find the next best paths for A and B by reapplying the same logic, but counting the previous ones in the expression. I don't know what that means. The other data we need is the path traveled so we can show it to the user. Given we need two paths, one for A and one for B, and the two accumulated lengths, our accumulator can take the form of distance A, path A, distance B, path B. That way, each iteration of the fold has access to all the state, and we build it up to show it to the user in the end. Did anyone understand any of that? I didn't. I mean, I have an idea of what I would do, but that just seems really weird. Oh, it's going to be the distance is one accumulated. This is just a single number and this is a list. Is that right? I think that's what it's trying to say. Shortest step ABX, and here's our accumulator. So this whole thing is one tuple. It's a tuple that contains two tuples, distance A, path A, distance B, path B. So we have basically we're looking at 4 options. A1, A2, they're basically calling it by traversing X. So we have 2 options for A. Taking A directly, so it's distance plus the new A, or we do the distance B and we travel X. So we do B and then X. And then we have the option for B's, taking B directly or taking option A and then adding X. So we have, option B directly and then adding X. And then here is the path. So if we do the first A, we have to just basically add this is the atom A followed by the value of it. So it'd be like little a 50. So a path is basically a list of tuples, atom, which whether it's A or B, and then the distance. The same thing here, except that we have to add 2 items to the path because we're doing B and then X. So now here we're going to find which one is actually better. We only have 2 options because we can determine at this point whether option A1 is better or option A2 is better or B1 and B2. So we end up with what's the best way to get to the next A, what's the best way to get to the next B. They call min on these 2 even though these are tuples. Kind of weird, but I guess it works. All right, let's write this function without, hopefully without looking at it. Let me just copy the name first. Shortest step. Okay, let's see if we can make any sense of this. So our shortest step is going to get an ABX, right? Which is the path, and then it gets the accumulator. The accumulator is a tuple, and inside the tuple is basically the A path, right? Total distance A. So total A followed by path A. And then we have total B followed by path B. That's what this shortest path function looks like. And we know we're going to have basically 4 options here. So we have A1, I guess I would be interested in not constructing the whole thing, but let's construct the whole thing here. So A1 is equal to A1 plus A. Maybe I should, where should the A1 go? Maybe I put it in this way. A plus A1 plus total A. I don't know what I'm doing. We know that A1 would basically be equal to, the distance of A1 is equal to A plus total A so far, right? So however far we've gone and when we add A to it. The other option is A2, where we take B instead. We take X and is it total A or total B here? When I'm turning. I only want to figure out what's better to get to this point or this point, A1 or B1, right? And I don't care about the previous numbers. I only care about the top numbers. So I don't care about this. B1 is equal to B. B2 is equal to B plus X, right? A plus X. Those are the distances to those points. And what do we want to return? We want to return, let's look at the shape of the thing we want to return. We want to return the new total A and then add to the path, right? So I could do like min A is equal to, what's it called, math min? There's no min? Oh, here it is. Min A1, A2, and min B is equal to Erlang min B1, B2, right? Now I have the short A and the short B. Do I have enough here? Maybe this is bad. Yeah, I've lost my path. I need to keep the path of how I got here because I've lost it at this point. So I need to know. So how do I do this? Ah. Yeah. Yeah, okay. Got it. So if it's A, then we have a total A, right? So we're just going to return. I think we actually do total A here because we want to return how everything else we got for A. I'm going to do that here too. And then we're going to add to the path. So in this case, we return the path, which includes now A followed by path A. So we're basically adding A to path A. And in this case, we need to add, we're taking B followed by X, and then the rest of path A. Now we do the same thing here, where we return b plus total b, and we're adding b to the path here. And here we're taking a plus x plus total b. And we are making a comma x and the rest of path b. Does this look right? And now we need to return two of these, remember, because we have this, so we want to return something in the form of the accumulator. So we're going to return the minimum of A1, A2, followed by the minimum of B1, B2. Shortest step 2. Whoops. Okay. Does that look right? Let's compare. They did option. Distance A plus A, which is kind of what I have, and then oh right. They added little a here to show that they took A. That's important. I was wondering whether this needs to be reversed. A plus X, so this is A, right? Okay, does that look right now? I think so. I wish I could easily had some test cases for this. But let's just assume this works. What's left to do is stick that function into a fold. So what are they doing here? We're calling shortest step. And what are the options to it? This is the initial accumulator, I assume. So it's saying that total A is 0. 0 in the path is empty for both. And then we give it the map that we get passed in, which I assume is this parse map, right? So we're going to put this optimal path under parse map. And so then we get back a comma b, which is the shortest path from A from B. Dist path, if head element 2A doesn't equal x0, then A, what? Element 2A. At the end of the fold, both paths should end up having the same distance, except one's going through the final x0 segment. Is that true? Ah, yeah, because we have to choose. Ah, yeah. We have to choose because we're adding total A, total B. Why are we going through 0? Picking the path with the fewest steps would also work. Ah, I get it. So, like, basically, at the very end, you either got to this point or this point, right? So, you have to look at your total B, and then you add 8, you might go here. And if you're here, you're going to be like, it's better to go down and across. No. A, if you're here, your option is to either go B or BX. And obviously B's better here. And then you're going to have this option, and it's either going to be 10 or 10, 0. Yeah, I don't see why you would ever pick the 0 one, right? Because your minimum here is going to be, it doesn't change. It's going to be 10. What am I missing? Well, I'm not sure. So why don't we just not do that part because I want to understand it. So what we'll do is we have the shortest path here, right? We should add this optimal path function. Optimal path. And what does it take in? It takes in the map. So let's see, what is this going to do? Let's see here. We're going to call fold L, and we need to pass in our function followed by the accumulator followed by the map. We know we're going to pass in the map. And the accumulator is pretty easy. It is a tuple where we have the total distance traveled for A and the path, followed by the total distance traveled for B and the path, right? That's what that looks like. Now the function is a little bit more work, so fold L, we're going to pass in shortest step. Why is this not happy? Did I get the fun shortest step 2? Ah, just I need like something like this. Optimal path. Fold L, what is this, list? Okay, so that works. Now let's just try, I guess, calling this from here, and we'll just see what it returns. Right? Undefined function fold 3. List is it? Where is it? Lists. Here we go. All right, so the total distance for the first one is 80, and the second one is 45. This is the thing here, is it? Yeah. So, oh, look at that. Oh, I see. It's reversed. We put X first. So we start here. B10. Then we did X30, right? So it was faster to get to A1, it was better to do 1030 than to do 50. Then it was better to do A5. A5. Now our choice is 20 or 40. No? How do we get B2? B2. That doesn't work. X25. I think my function's wrong. A, bx, distance A, path A, distance B, path B, equals A, total A plus A. Then we add A and path A. B, B and total B. That's why. Right, because we're coming from point B, so we need to add, where do we come from? We came from the B side, so we have to total our B. That makes total sense. So, and if we do this, this must mean total A. Yeah. All right, that makes sense now. Let's try that again. Yeah, look at that. This is correct. Look, they were right. I was wrong. So B10, X30, A5, A40, A40, B8. Uh-oh. A40, B8. How did I get B8? Oh, X0, B8? That looks wrong, right? B10, A5. Yeah, something's still wrong here. What the fuck? Total A path A, B total B, X B path B. Let's see. Right, because we came from B, so we need to include path B. That is seems so obvious now. And this will require path A. Duh. All right, last time's the trick. So we have B10 B10 X30, so that's B10 X30, A5, that's A5, X20, that's going down, B2, B8, X0. B10, X30, A5, X10, oh, X20, B2, B8. So the difference here was that this guy has a 0 because he went B10, X30, A5, X20, B2. So from here, he either does B8, I see, B8. Why does he have to do X0? Oh, okay, I get it. Hi, Wekram. Sorry, I was sort of like. We're working on the shortest path using Erlang. And I was trying to figure out why is it that one's going to have an extra x0? It's because somebody started off in the wrong place. When you're in a grid, basically one guy is going to be the loser if you think about it, right? So since B10 since B10 is the right answer here, the other guy went B10 X30, B10 X30, A5, A20, B2, B8. This is something so obvious. So when we do the shortest step the first time, we basically have A to here. It's better. Oh, right. It's better to go B10 and then 30. We got here. And the other guy goes here just by taking one step. Right? So we do B10, B30, B10, B30. So this guy's up here. And now we run shortest step on those two. And he's going to say, I either go 5 or 90, 20, do 90 here. Well, we'll think about it more later. But anyway, when we use this algorithm, one guy's basically started off on the on the wrong path, so he's going to take one step longer than the other one. So that's how come we check the length, I guess. I don't really feel like I get it though. Why am I not getting it? Here, let me put this in Chat GPT then. No, that's not it. Okay. So here's that's my Erlang code. Why does the optimal path have one extra x equals 0 step in it? You're paying a lane switch before the very first station. That's what I was sort of thinking. A2 and B2 are always allowed, and you always prepend X and X step. But at the start of the flow, the paths are empty. That means on the first row, you can switch from the other line even though you weren't on it. So you can create an X right at the beginning. In that first, if that first row has X equals 0, you end up with a spurious X equals 0 step. So it's basically saying in the very beginning you may want to cross like B10. I don't get it still. You're paying and recording a lane switch before the very first station. So here's the data. Hey Findus, how are you? Bonjour. I'm doing poorly on this also. Oh, 5:10:30. Is that what it was? Yeah, 5:10:30. So A10X No, that's B10. First iteration, we go A equals fifth A equals 30, 10 equals X plus B, and B is equal to B, right? Right. So where's the 0? This is right. I follow this. So after the first row, the state is this. Yes. Yes. But why is the, where's my actual response here? This. Where does the last x0 come from? That's what I don't get. Because we did B10x30. It's because in the beginning we took the x, and now it needs to switch path. It needs to switch. That doesn't make sense, right? Because then we have the path up here. Just home from work, so hungry. Bon appetit. So this is our path up to here, and this is our path up to here. And now we're going to either go here, or our choice was basically, let me just like check the code here, because maybe I'm just, oh, got it. It's because we have the total A and the total B here, right? And basically we want to know how to get to the next step. If we want to get to A1 up here, we can either take this 10, or we can go, oh no, or we can go 8 and then 0. Ah, that's the difference here. It's this path. I'm just so out of it. Oh my God. So either we could have taken the 10 to get to this last point on top, or we could go 8, 0. And obviously 8 is direct, like if we started here and went there. So we should just pick the one where it doesn't have the 0 at the end. That's what they've been saying all along. Oh my God, I can't believe it. Should I just edit this part out where I'm just confused? Does it make sense to you guys? Does anyone not get it? If you don't get it, let me know and I'll explain even further. But I guess you just have to think of it like for each iteration, the question is more, how do you get to the next one? So the very first iteration is like, how do you get here best? How do you get here best, right? Should I just go from my A, or should I go from B followed by X? How do I get here best? Do I follow A and X, or do I just go B? And the very, very end, the question is, how do I go here or here? So the best way to get here could either be going straight from A, or it's taking B and then X, right? But the X is 0. Um, and how do you get here best? You either take B, or you go from A and then X. So since X is always 0 at the end, since this transition is 0 cost, we're going to have one option where it has the extra X equals 0. And what we want to do is remove it. That's what this guy was basically saying here. Where was it? Here it is. So how do they do this? They look at the head of the A, because we have A and B, and we see if it's equal to X equals 0. Right, so it's looking for the one that doesn't have X equals 0. So the other thing they said you can do is take a look at the so now we're going to have A and B here. We have two options, just like we saw over here, right? These are our two possible solutions. And this is a list, and this is a list, and we'll pick the shorter one. That's how we'll do it. So A is in the format of tuple comma list. So maybe we do total A, path A, total B, oh, it has to be capital, path B, right? And then we check which one's longer. If length path A is greater than length path B, then return, then we want B, right? So we do total B comma path B. Otherwise, return total A path A. Is that not how it looks? Is it this? I don't know. God damn it. Let's look at our new greet. I know I have one in here. If statements, if n true end. Okay, what did I do wrong then? If isn't this right? Oh, I need that for sure. Yeah, what's wrong here? If blah 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 true end. I'm confused. Syntax error. Why aren't you helping me more, compiler? What's wrong with the syntax of this function? I have an equals? Oh, it's in here? Oh, I don't have this matching up. There we go. Wow, that makes a big difference. Duh. All right, so now we have only one solution. It got rid of the x equals 0 one, you see? So we've only kept the bottom one. And now we have to reverse it. So we just call oh, do we not care about the distance? We only care about returning the path. Distance, and then we have path here. And now we're going to lists reverse, right? Yeah, list reverse path. So B10, X30, A5, X20, B2, B2, B8, B2, B8. Works for me, guys. I think that works. Yeah, that was what we came up with. Being able to run our program from outside the Erlang shell, we'll need to change our main function again. Oh, we're going to learn how to call it from outside our shell? This is cool. So we have to pass in. We don't need all of these functions anymore, right? Because they're all linked now. We just need to export main. And here we just add a file name. And we pass in file name here. Parse string. Oh, and now we're gonna. They print. Oh, they get the optimal path. So this is like we can do solution, and then we can print this out. IO format P. P is for like the Erlang, just format of whatever you're passing in. So we'll pass in map here. No, solution. And looks like they want us to call halt. Main one is not used. Ah, all right. So now we can call it from the command line. Something like this. And now let's try compiling it. Ooh, we're going to learn how to compile from outside. Earl C, road Earl. And now we can do Earl. Oh, this is not easy. No shell. Run. Oh my God. Seriously? Seriously? Okay, I didn't give it the name of the file though. Where is that? Minus run road main road.txt. There we go. Easy, right? No shell, so that means don't go into REPL. Run, you give it the name of your Erl module. What's the entry function? And this is the args to the function. Super easy. No, not really. I was really hoping for like, I don't know, some kind of, it spits out a bash or executable. You could make yourself a bash batch file. Yeah, right. So we could make a and we run Erl no shell minus run road main road.txt. User bin env. Wait, what? Is it the other way around? Yeah, there you go. Okay. Oh God. Well, that was a little painful again. Took us an hour and 30. I think I'm a little bit less slow than yesterday, but not much. Also, I didn't like force myself to go through all the pain on my own. Maybe we'll just, yeah. Anyway, we got through it. So what are we going to see here? We're going to learn records. I'm interested in this. I'm guessing it's like, it looks like it's basically a map. Yeah, I'm guessing it's like a map. Key value stores. Arrays. Didn't we array? Isn't arrays basically like a list already? Set of sets. Yay. Looks like very little code though, so we'll just kind of be visiting some stuff and maybe reading stuff here. Like we're not doing any coding here, but we are going to be coding the records. All right, sounds good. Hello, Poisnada. I'm actually done for the day. I got to go out and go to the pharmacy, pick some stuff up. Actually, I promised that I would look at the nerves PR for text, so I'm going to look at that real quick. I hope it doesn't take long. Let me find it. Here it is. All right. Here's the PR we're going to review. Nerves is the Elixir system for embedded embedded systems programming. Over the past few days, I've worked on a new version of Getting Started section that would be more suited to beginners. I did a presentation at Goatmeyer Elixir on nerves, and and I and so now they asked me to help just do a quick review. I guess this is Mark here. I've moved a few things around and pushed some sections to core and tried to adopt a sequence that makes it easy to understand one concept at a time. This PR is a discussion starter, still needs some rework before it's merged, but I wanted to put it out there so we can iterate. Let's look at how big it is. All right. So how should we do this? Should we look at, oh, there's only one commit where it has all the changes. Okay, so interesting. Guides, core, user interfaces. Looks like this just got rid of the Phoenix stuff. Using nerves. Let's see where all this is. Where's GitHub for nerves? Here we go. Is it? No, I think. Is that where it's the getting started? Here's docs. All right, so maybe this is this. Using nerves. Not really sure where using nerves even is. Hmm. Core using nerves. Maybe we should get this code. To look at it better. Because it's a little hard for me to see just like this. We're out of nerves. Git checkout. What? I'm what? Where's this branch from then? How do why am I confused? Oh, because it's from I see. Let me just remove it. I don't know the secret commands for rebase like changing the origin. And I think I need to check out getting started guide, right? Yeah. So this is the one commit. Yeah, it has the same change. Okay, so using nerves.md. Here we go. Now I can see the whole file easily. This one was user interfaces. What is going on there? User interfaces. Kiosk. Okay. All right, I don't really know that, so I'm not going to comment on that. And here it looks like it's a whole new file, huh? Okay, so this is a whole new file. It's called Using Nerves. In the following guides, support channels, and forums, you may hear the following terms being used. Host, the computer on which you are editing source code, compiling, and assembling firmware. Target, the platform. Well, let me just make the computer on which you are editing your source code, compiling, assembling firmware. Target, for which your firmware is built. For example, Raspberry Pi 0W, Raspberry Pi 4, BeagleBone Black. Toolchain, the tools required to build code for the target, such as compilers, linkers, binutils, and C runtime system. A lean build root based Linux distribution that has been customized and cross compiled for a particular target. Firmware bundle, a single file that contains an assembled version of everything needed to burn firmware. Firmware image, built from a firmware bundle and contains the partition table, partitions, bin loader, etc. Creating a bootable SD card. Bash RPI 0 mix firmware burn. Well, isn't it dangerous to say RPI 0 here? I see they moved it out from getting started. Using nerves. I feel like um, mix firmware burn won't just work, you know? Like if I just do mix firmware dot burn, yeah, it's like it doesn't, I just can't run this. So shouldn't this tell me like what to do beforehand? Um, I'm a little lost as to why we go from from definitions to burning the firmware. Is this doc supposed to be the streamlined version of deploying nerves onto a target? Let me read the getting started first because maybe that's better. Let's go here. Nerves provides tooling and libraries for building software images to run on embedded systems. It uses the rock solid Erlang virtual machine support of Linux. That's rock solid Erlang version support of Linux. And brings the happy development experience of Elixir to your microcomputers. I would kind of change the phrasing here. It uses the rock solid Erlang would rephrase to it uses the rock solid Linux support that the Erlang virtual machine provides. It it uses the rock it uses the rock solid Linux support. It uses the rock solid Erlang virtual machine support of Linux. How else would I say it? It uses the Erlang virtual machine. While the Nerves project provides base runtime libraries for hardware access and network configuration, nearly all the Elixir is available. Nerves uses the Linux kernel to support a large variety of hardware. It is not a Linux distribution, though, and contains little of what you would find on a typical embedded Linux system. Instead, it starts the Erlang runtime as one of the first OS processes and lets Erlang and Elixir take over from there. Not to fear, if you need something from Linux, Nerves provides a way to use most of the packages available through Buildroot. The A great path to exploring Nerves for the first time is by setting up the Nerves Livebook project. This allows you to try out. Within minutes, you'll have a Raspberry Pi running out. You'll be able to code in Livebook and work through Nerves tutorials. If you'd rather build your own firmware, make yourself at ease. Is that how you would say it? You're in the right place. Just keep scrolling. Read the installation guide. It will help get your machine. Let's get you set up. Isn't this setup is a noun? I don't think that's right. Yeah, should be set up. Let's get you set up and through your first hello world moment. If you already have some experience with Nerves, you should skip this section and go straight to the core documentation. Before you start using Nerves, it's important that you follow the instructions from the installation guide. It will help you get your machine configured for running Nerves. Come back here when you're done. All right, does this actually work? I assume it does. Back already? Let the fun begin. Let's create a new Nerves project. The Nerves new project generator can be called from anywhere and can take either an absolute or relative path. Mix Nerves new hello Nerves. Nerves will generate the required files and directory structure for your application. We'll give you more details about them in the Anatomy of a Nerves project section. As described, the next step is to change the project directory, choose a target, and fetch. What is a target? It is a platform for which your firmware is built. For example, a Raspberry Pi Zero. The firmware is a binary image containing both the Linux OS and as well as your Nerves project. This is what we will build with Nerves and then flash on the target. Okay, it is the platform. For the rest of the section, we'll assume that you're working with a Raspberry Pi board, but the instructions apply to other targets as well. If you ever get confused about the common terms we use in this guide, we've consolidated a list common terms. In the section, in the introduction, we mentioned Nerves uses Linux as its foundation. But we don't use a pre-existing Linux distribution. Instead, we use a build system to compile only what we need. That is what build root is for. It allows us to use just the right amount of Linux software we need to keep our images as small as possible. Don't worry, you won't need to understand how buildroot works at this point, but in order to be able to continue, you will need to know which nerve system you will need for your target. The nerve system is a precompiled Linux OS built with buildroot on which you will run your application. But to avoid having to precompile our system each time we build firmware, we leverage on precompiled. What does this mean? In the introduction, we mentioned Nerve uses Linux as it allows us to use just the right amount of which nerve system you will need for your target. Probably can drop the on, i.e., we leverage pre-compiled systems. Assuming you are using Nerves for the first time on a Raspberry Pi, this is the list of systems for each Pi version. Maybe repeat here and say this is the list of Nerves system for each Pi version. Here we go. RPI 0 Pi 2. Where's my Pi 0 2? Ah, that's kind of tricky, huh? I got screwed from this, so I'm going to say. Um, the first time you compile your application or its dependencies, nerves will fetch supported targets. So if you are not using a Raspberry Pi to file, you should go take a look and identify the system you need. What is relevant at this point is what's in the tag column. The target is chosen using a shell environment called mixed target. Don't forget to replace the RPI 0 in the example below with the right tag for your system. Pro tip. It is not mandatory, but you can set mixed target environment variable once. Export mix, yeah. You'll have to do this again if you close your terminal or if you have one for running commands against your local machine and one with the desired mixed target variable set. This allows you quick access to use your host-based tooling in the former and deploy updated firmware in the latter, all without having to modify the mixed target variable in your shell. Let's get all the dependencies that our system needs. Hello nerves, mixed target RPI 0, mixed deps get. You may now install mixed burn, right? You will need to choose a way to connect with it. Yeah, this is annoying. We'll describe the easiest method, Ethernet over USB. But there are more. By default, most nerves provides an Ethernet over USB interface. It means that you just need to plug your Pi to your computer with an appropriate USB cable to build. Okay, I didn't know about that, but that's great. How do you know when it's booted? Mention that for RP Raspberry Pi 0 that that it takes about 10 seconds or so, and you'll see some activity light blinking. Oh, this is already handled. Um, Pi to Pi, uppercase for consistency. May be worth mentioning a bit of this before the directive to connect. Like, it'll take um all right, so here now that we have managed to boot our Pi with our own firmware, let's see what a Nerves project actually looks like. Just like any depths is where you application is module is located. If you have any experience, this should feel like home. Nerves application, good old updating your firmware. You'll find yourself making changes to your application wanting. However, we don't want to always remove the SD card over the network. Something easy we can change is the hello function in our hello nerves. So we change this function. Let's just change world to nerves. Okay. Why does this look weird? Strange. Mix target, mix firmware. Upload. If any, if at any point in your journey you feel stuck. Oh my, am I on the wrong pull? No, I think I'm in the right place. Um, reach out to the nerves community through welcome to nerves. All right, I think we're good. I'm looking at the PR, right? Um, I forget how to do this. How do you leave your, how do you like start a review and say you didn't approve? God, GitHub, like, no matter how many times I fucking do this, I swear to God. Review changes. Here we go. All right. Already got a message back from Mark that he sees that I've left comments. I think we're good now. Are we still streaming? I haven't been looking here. All right. Thanks so much, everyone. I'm going to get back to the rest of my day or start my rest of my day. I really appreciate you hanging out with me. What is going on with Restream here? Is it acting stupid? No, it's working. All right. So thanks a lot. We did some Erlang, we did some nerves review stuff, and I will talk with you guys more later when we do more Erlang. We will be looking at common data structures, learning maps or records or whatever. So that's exciting. All right, talk to y'all later. Bye. Now where's the turn off button?